Hey everyone, this is Mr. McKinney with your 1 through 10 on Newton's first and second law of motion. Coming to you from my space table out here. Since we're talking about Newton's laws of motion, I will float, to make sense, I would float on over and get our prop for today, which is going to be Newton's cradle. Essentially 5 little steelies suspended by little ropes. We're going to start with Newton's first law of motion. Newton's first law of motion states that an object at rest will remain at rest, and an object in motion will remain in motion at a constant velocity unless acted upon by external force. So we're going to break that down into its 2 parts. First part is that an object at rest will remain at rest until an external force is acted upon it. So these marbles here, these steelies here, are just going to sit there unless some force acts upon them. All right, so let's do that. All right. The second part says that an object in motion will remain in motion until some external force has acted upon it. So we're going to put these in motion here. We're going to put one of them in motion, and we're going to watch what happens here. So you'll notice that they do slow down and stop, which means there must be some force acting upon it. In this case, one of the forces is gravity, right? Gravity is pushing down on it, so that's making it slow down a little bit. And then you actually have a little bit of friction between the little strings and the bar. So every time it goes back and forth, it rubs a little bit and slows it down, right? If we were in actual space instead of my space table, it would go for a lot longer, right? Eventually it might stop because of the friction, but it wouldn't necessarily stop because of the gravity, okay? So that's Newton's first law of motion. Newton's second law of motion, so the official equation is force equals mass multiplied by acceleration. I'm going to give you a demonstration again with a Newton's cradle, okay? So to increase force, we can either increase mass or we can increase acceleration. So I'm going to start with acceleration. So earlier you saw me lift one of these steelies up to about here. We're going to go a little bit higher, all right, which, actually, no, we'll start here, okay? And well, I want you to see where the other one ends up, all right? And I'll try to measure it with my finger pointer here. All right, so it goes to about there. We're going to allow it to have more acceleration by moving it up this way, and then we'll see if it goes past this point here, which in fact it does. That means that this steely was hitting the rest of them with more force because I added more acceleration. Now we can also do mass. So same thing, I'll go about here. Goes about up to the finger point there. Right, now, what I'm going to do is I'm going to add more mass. I'm going to use 2 this time and see if it goes any further. A little bit further, not too much, but a little bit. So you can increase force by using more mass or more acceleration. Things in space, very small things in space, zooming by, can do a lot of damage because they're moving so fast, sometimes up to 17 to 20,000 miles per hour. So you can imagine even a little small pebble moving at 18,000 miles an hour. I hope that clears up a little bit of Newton's first and second laws of motion. If you have any questions, leave some comments, or if there's anything that you would like to see me try with the Newton's cradle, you can leave that as comments as well. I'm going to leave you with one thing. I'm going to, because it's kind of interesting, we're going to do 3, right, and see what happens. So until next time, stay strong and science on.